Hello. Hello and welcome to this video. This is the 42nd set of problems on polynomials and theory of equations. So we have covered till now 41 sets, that is up to problem 410. I will show at the end of the video how you can download the PDF. The link will be in description. So without further ado, let's get started. As always, I'll say that when I'm reading the problem, you should pause the video and only if you cannot solve the problem, you should look at the solution. So question 411 says that find all solutions of equation mod of x square minus x minus 6 is equal to x plus 2 where x is a real number. So if x square minus x minus 6 is equal to 0, then we have two solutions for x, that is minus 2 and 3. Now first case we pick is when x is less than minus 2 or x greater than 3. Then we see that x square minus x minus 6 will be greater than 0. So the equation will become x square minus x minus 6 is equal to x plus 2 or x square minus 2x minus 8 is equal to 0. That means x is equal to minus 2 and 4. But x is equal to minus 2 is not acceptable because x is less than minus 2. So x is equal to 4 is acceptable because x is greater than 3. Now the second case we take is when minus 2 less than x less than 3. In that case, we see that x square minus x minus 6 is less than 0. So the equation becomes minus of x square minus x minus 6 is equal to x plus 2. Or x square minus 4 is equal to 0. So x is equal to 2 because again x is equal to minus 2 is not acceptable. Now if you see the equation, the left hand side has minus 2 as a root. And if you look at right hand side, that is x plus 2, x is equal to minus 2 is again a root. So x is equal to minus 2 satisfies both left hand side and right hand side. But x is equal to 3 won't satisfy the right hand side, although it satisfies left hand side. So we have that sorted. Now we move on to question 412. It says that solve the equation 2 to the power mod of x plus 2 minus 2 to the power x plus 1 minus 1 is equal to 2 to the power x plus 1 plus 1. So if mod of x plus 2 is 0, then x is equal to minus 2. And 2 to the power x, mod of 2 to the power x plus 1 minus 1 will be 0. Okay. So if we substitute that, x is equal to minus 2 here. Okay. So this becomes 1. Alright. Sorry, it becomes 0. So that becomes 1 and it gets cancelled here. And you can do the rest of the math for this. Now, first case we take is when x is less than minus 2, then x plus 2 less than 0, and 2 to the power x plus 1 minus 1 is less than 0. So our equation becomes 2 to the power minus x plus 2 minus, since it is less than 0, 2 to the power x minus 1, we take a negative of that because of the mod, and then we write the equation rest of it, which gives us x is equal to 3. Now we take another case where minus 2 less than x less than 1. Then what happens is x plus 2 is greater than 0, but 2 to the power x plus 1 minus 1 is still less than 0. So the equation becomes 2 to the power x plus 2 minus of 2 to the power x plus 1 minus 1, which is and right hand side is 2 to the power x plus 1 plus 1. So if you solve this, you get x is equal to 1. The third case is when x is greater than minus 1, then x plus 2 is greater than 0, and 2 to the power x plus 1 minus 1 is also greater than 0. So the equation becomes 2 to the power x plus 2 minus 2 to the power x plus 1 minus is equal to 2 to the power x plus 1 plus 1. Now this minus will become plus 1, which will get cancelled. And this minus 2 to the power x plus 1 goes on to right hand side, it becomes 2 to the power x plus 2. So this is clearly true for all x, but we will accept only the cases where x is greater than minus 1 because that was our original condition. Now if you see the equation, then x is equal to minus 2 does not satisfy the equation, but x is equal to minus 1 satisfies it. So that is one solution which we have. Question 413 says that solve 3 to the power x plus 4 to the power x plus 5 to the power x is equal to 6 to the power x. So if we look at the equation, then x is equal to 3 clearly satisfies the equation. You can see that 5 to the power 3 is 125, 4 to the power x is 4 to the power 3 is 64, that is 125 plus 64, 189, and then 27 from this, 3 to the power 3, that becomes 216, and the denominator 6 to the power 3 is also 216, so that is equal to 1. Now we take the case when x is greater than 3. When x is greater than 3, the sum on left hand side is less than 1, and when x is less than 3, then sum on left hand side is greater than 1. So we see that x is equal to 3 is the only solution. Now 414 can be solved similarly like 413, with the extra hint is that if you look the term under square root, if this is y, then this would be 1 by y. So that is your extra hint, and this x is whole to the power x. I'll edit this in the source for this. I'll fix this. So if you see this, x is equal to 2 is the only solution, which makes it true. So why this is so that x is equal to 2 is the only case which we have. So suppose x is greater than 2. Okay. So if you look at it carefully, if x is 2, both are positive. Okay. If x is 2, then the square root gets removed, square root of 3 gets cancelled, and then we have 2 plus 2, 4. Now you look carefully, if x is more than 2, then this term itself will be more than 2, okay? Because if it's power 2, then it will become 2 plus root 3. So that is roughly, if you look at this, that is equal to 3.732. So you see how this works out. Now we look at question 415, which says that let x in braces and x in brackets denote the fractional and integral part of a real number x respectively. Solve 4 into left brace x, right brace is equal to x plus left bracket x, right bracket. So what we do for this is we can write that x is sum of integral part, that is x in brackets, plus fractional part, which is x in braces. So our given equation, which is this equation, okay, it is given to us. We can write that as 4 brace of x is equal to x plus x in brackets. Okay, that is what is we have given. Now what we can do is we can solve this equation. This x can be written as x in brackets plus fractional power of x. Sorry, I mean the fractional part of x. So you take that to left hand side, it becomes 3, and into fractional part is equal to 2 into integral part. So fractional part is equal to 2 by 3 integral part. Now we know that the fractional part will lie between 0 and 1. So we substitute there this value, we get 0 less than 2 by 3 integral part x less than 1. So our integral part becomes between 0 and 3 by 2. So clearly integral part is 1. Once we have that, we know the fractional part, which is 2 by 3, by plugging it in this equation. And once we have the fractional part and the integral part, we know x is equal to 5 by 3. Now, question 416 is, the notation is same as previous problem. We have to solve the integral part square is equal to x into x minus integral part of x. So what we do in this case is that left hand side is integral part squared, right hand side x minus integral part x becomes the fractional part, and this x becomes integral part plus fractional part. So integral part plus fractional part into fractional part. Now if you look at this equation, it becomes y square is equal to y plus z into z, where y is equal to integral part and z is equal to fractional part. So the equation is z square plus yz minus y square is equal to 0. That implies that z is equal to minus y plus minus square root of 5y by 2. This y seems to be outside square square root, which is true because when you will do this math, this y square plus 4bc, that is b square minus 4ac, so b here is y, and a is 1, and c is minus y square, so that is 5y square. So this square root is square root, this y is definitely outside the square root. Now we know that the fractional part, that is z, is between 0 and 1. So we can't take up the negative sign. So what we have is z is equal to minus square root of 5 plus 1 y by 2. Then what we have is 0 is greater than y and greater than minus 2 by square root of 5 plus 1. Okay, it took the negative part of it. Okay, we will consider it. Let's see where it goes. Okay, so it took the minus sign of it here. All right. So once we have that, it becomes minus square root of 5 minus 1 by 2 less than y less than 0. But it is not true, okay, because y is an integer. And if you look at this value is something 2.23. So minus 1 would be 1.23. So that means it will be 0.6 something. Okay. So greater than minus 0.6 and less than 0 is not possible because y has to be an integer. So there has to be an integer in the range. So this value is definitely not possible. That's why I said taking a negative value won't work. Okay. Now we choose the positive value for the discriminant. We get z is equal to square root of 5 minus 1 by 2y. Then what happens is 0 becomes less than y, less than 2 by square root of 5 minus 1. Now once we have that, y becomes 1. So z becomes square root of 5 minus 1 by 2 and x is equal to y plus z, that is square root of 5 plus 1 by 2. Now we move on to question 417. We have to solve two equations. The first equation is x cube minus y cube is equal to 127, and the second equation is x square y minus xy square is equal to 42. So then let's see how we solve this. We substitute y is equal to mx. One equation becomes x cube into 1 minus m cube is equal to 127. The second equation becomes x cube by m minus m square is equal to 42. We divide, we get 1 minus m cube by m minus m square is equal to 127 by 42. So we factorize this. The numerator becomes 1 minus m into 1 plus m square divided by m into 1 minus m. So 1 minus m will get cancelled because m is equal to 1 doesn't satisfy the equation. Okay, if m becomes 1, this becomes 0, all right? And then the left hand side becomes 0 and 127 is not equal to 0. Similarly, for this also, this becomes 0. So clearly m is equal to 1 will not work. Y is not equal to x, all right? So y is not equal to x. That is, you can clearly see it will make left hand side 0 in both cases. So x is equal to y is not possible. So now what we have is 1 plus m square by m is equal to 127 by 42. That's a simple matter of solving. You get m is equal to 7 by 6 and 6 by 7. So we substitute this in this equation. So we get x is equal to, sorry, we don't substitute here, we substitute here rather. So we get x is equal to minus 6, y is equal to minus 7, and x is equal to 7, y is equal to 6. Now we move on to question 418. We are given a system of equations of three equations. X minus 2y plus z is equal to 0, 4x minus y minus 3z is equal to 0, x square minus 2xy plus 3xz is equal to 14. So we do the cross multiplication for the first two equation. We get x by 7 is equal to y by 7 is equal to z by 7. So that means x is equal to y is equal to z is equal to k. We take some constant k. Now once you have k, you plug it in the third equation. So you will get how much? K square minus 2k square plus 3k square. So that is 2k square. So k is plus minus root 7. Once we have the k, we know x, y, and z. Question 419 says that solve x to the power 4 plus y to the power 4 is equal to 82 and x plus y is equal to 4. So we have got two equations, two unknowns. So what we do is very simple. We plug it in equation x is equal to u plus v and y is equal to u minus v. Why we plug it in this way is because it's very simple to calculate u and v, one of those with this equation. Okay, it is kind of trivial to obtain. So the first equation becomes u plus v to the power 4 plus u minus v to the power 4 is equal to 82, which gives us u to the power 4 plus 6u square v square plus v to the power 4 is equal to 42. Now the second equation becomes 2u is equal to 4, so u is equal to 2. Once we have u, we plug this in this obtained equation and we get v is equal to plus minus 5y and plus minus 1. Once we have v and u, we get to know the x. So our x becomes 2 plus minus 5y, 3 and 1. And y becomes 2 minus plus 5y and 1 and 3. So now we come to the last question. Question number 420. It says that solve square root of 8 into 2 to the power x minus 2 plus 1 is equal to 1 minus 2 to the power x, where x is in the set of real numbers. So we let here in this case y is equal to 2 to the power x, which is greater than 0. Our equation becomes square root of a into y minus 2 plus 1 is equal to 1 minus y. We square both sides, we get y square minus a plus 2 into y plus 2a is equal to 0. So y is equal to 2 and 8. Those are two roots from this equation. But y is equal to 2 will not satisfy this equation, because if you plug in y is equal to 2, it won't work. So we plug it y is equal to a. Then we see that square root of a into a minus 2 plus 1 is equal to 1 minus a. And from this we deduce that a is less than or equal to 1. Now we know that it is between 0 and 1, so y is equal to a. That implies that x is equal to log of a with base 2, where a is between 0 and less than 1. But the other case could be that a is greater than 1, and when you plug it in the equation, it gives us no solution. So with this, we come to the end of 42nd set of questions. I know some of it I have not explained. For example, question 420 could have been explained more. And 420 is maybe 414 could have been explained more. But I think some work is due for you as well, because if I solve everything, then it does not make sense. So at least take some effort and try to understand the solution, that how we arrived at the solution. It will require some inquisitive mind. And with this, we come to the end of this video, and I hope you're enjoying the series. By the way, you can download the book. So the link will be in the description. You can make use of that, or you can go to my website ashtok.org. Come to the second link. You can click this link to download the PDF. Also, you can download the trigonometry book, which is also complete. I will cover trigonometry after I am finished with algebra. So with this, I will end the video. I thank you for watching my videos, and I wish you all the best in your studies and exams. Thanks a lot for watching the video. Enjoy.